Hello, everyone, and thank you for being here so promptly to join the 6G Symposium 2024. My name's Alex Lawrence. I'm the managing editor at 6G World, and really glad to have put this symposium on together with our event partners, the ATIS Next G Alliance and InterDigital and Northeastern University. I'd like to just keep you occupied for a couple of minutes talking about the concept of an all-licensed fool. This is something that European courts in the Middle Ages had, which essentially turned into court jesters later. And the idea was you get a lunatic into the court and then he's allowed to say whatever he likes because obviously he's not in his right mind. And that can be pretty powerful. If you've ever seen the play King Lear, then sometimes you just need to have somebody who can say what needs saying. Now, today, we have a situation where globally many telco businesses are sort of struggling commercially and have struggled over the past few years, and they see a need for change, that's for sure. They're looking at different business models and different ways to create profit. But when we're talking about 6G as a standardization process, that's come from the ITU, from government requirements, and then that's going through a technology process. That does not have that commercial component in it, to some extent by design, that the telcos are looking for solutions to, which, when you put it like that, sounds a little bit crazy. So we need to get the commercial thinking together with the policy and the research push so that we can make sure we're pushing in the right directions and showing value both to customers and to the market. So this will mean changes in how we do things and potentially saying and doing the unthinkable. So maybe all of us in the room here and out there online need to be a bit less crazy and maybe have a few more fools around the place. Having said that, I'd encourage you to ask any questions, comments as we go through the event today and tomorrow. Today, we're going to be looking at more of that commercial side and looking at how we build value from here towards 6G in very broad terms. Tomorrow, we'll look more at some of those key telecoms processes and institutions and asking how they can or should adapt to deliver value and what that might look like. And then we also have meetings offstage in the Hemisphere Room A, which hopefully will dig into some of the more important actions that we can take as an industry to take these conversations further. So that's a very quick summary of the event. I'd like to thank, as I say, partners, Next G Alliance, InterDigital and Northeastern, our sponsors, Keysight, Viavi, Cohere Technologies, Viasat, Virginia Diodes and Conveyor Marketing, as well as the streaming sponsor Nokia. For those of you in the room that need it, the Wi-Fi password and username are both 6G World 2024 in little caps. And with that, I hope that you have an awesome time at the event. I'm going to hand over to our keynote moderators now, Doug Castor and Tommaso Melodia, to properly introduce the event. Thank you.
All right. Thank you so much. So good afternoon, everyone. My name is Doug Castor, and thank you for being here at our 5th anniversary of the 6G Symposium. And Tommaso Melodia and I are co-founders of this symposium. And yes, can you believe it's been 5 years since we started talking about 6G? All right. And if you think about this 10-year cycle that we have with the generations, this means we're about halfway there, halfway to standardized deployment. And, like a good story that has a beginning, a middle, and an end, the midpoint is where the main events happen, or the turning points in the story. And, that's why this is the time frame where it's critical and crucial conversations for 6G. And this is a time frame when we're going to see how the use cases and the research and everything we've been discussing with the vision will start converting and transition into standardized deployable technologies, which we hope to see by the end of the decade. So let me just take you back a couple years through our 6G symposiums. Our first one was in the year 2020, and that was a year I wouldn't forget, because that was the year of the pandemic, when we're sitting at home hearing about this use case of immersive experiences, and what could not be more fitting than to thinking about how we could create a virtual immersive experience that could be on par with what we could have face-to-face here today. And that's really what we needed during the pandemic, was these immersive experiences to help us connect. And then the next year of the symposium was the year when we saw great government support. We had 3 active members of Congress come here, participate in our panel sessions and our keynotes, and that led to the next year our decision to have this event in Washington, D.C., so that we could bring in government and have them be part of our discussions. And that was the year we also had Ray Dolan, who I saw here earlier, and Diane Ronaldo giving a great fireside chat, and it was at the footsteps of the start of the CHIPS and Science Act as well. And then last year was the year of going beyond the hype, and this is where we asked the question of whether 5G's done or whether 6G's all hype. And our CTO from InterDigital, Rajesh Pankov, got up and gave a great talk about how 5G's not done. We have a lot to do still with Release 18 then, Release 19, Release 20, and 6G's not all hype, right? There's a lot of great research that we're all working on towards bringing that to deployable system by the end of the decade. So with that, I'm going to hand off to Tommaso Melodia, and he's going to tell you a bit about what's up and coming at today's 5th anniversary of the 6G Symposium. Tommaso?
All right, good afternoon. Pleasure to be here again for this 5th edition of our symposium. So, as is a tradition for our symposium, in the next 2 days, we're going to have a series of conversations that will involve leaders from academia, industry, and government to talk about some of the critical shifts that will happen in the industry and that will shape the future of 6G technology. So we'll begin today with a set of keynotes that will be aimed at exploring the central question of what's the most compelling use cases for the next G. And I'm sure that will be thought-provoking given the caliber of the speakers that we have today. Then we'll transition to a panel discussion that's been a centerpiece of all of our events, focus on US government initiatives, and specifically we're going to look at the next generation open, resilient, and interoperable networks with some key leaders from some of the most prominent US research programs in this field. And next, as Doug anticipated, this afternoon we'll dive into a series of panels that are focused on financial and economic aspects of the 6G transformation, right? Not only technical aspects, but a lot of trying to understand what are the socio-economical implications. How do we make the 6G transformation profitable, right? Building business models and generating demand ahead of full 6G deployment. And last but not least, supporting the triple bottom line. How do we make the transition profitable, but how do we also look at people and the planet? Tomorrow, then, we'll kick off with the White House keynote panel, 6G wireless policies and initiatives for 2025 and beyond, followed by various sessions that will cover non-terrestrial networks, new services for 6G, new spectrum, and addressing efficiency and affordability in the face of growing data demand. Finally, just be sure to attend some of the demonstrations that are going to be in the lobby here that will highlight a lot of cutting-edge work that is happening in the area of 6G. And I also would like to encourage all of you to actively participate, engage in discussions, and find ways to collaborate throughout this event. Okay, we can get started now. It's my great pleasure to introduce our first keynote speaker, Commissioner Geoffrey Starks. Commissioner Starks was appointed to the US Federal Communication Commission in 2019 and confirmed for a second term in 2023. Throughout his tenure, he has been a tireless advocate for the millions of Americans who either lack access to or cannot afford a home internet connection. We're honored to have you here with us today, Commissioner Starks. The floor is yours.
Well, thank you, Tommaso, and really honored to kick you all off on your 5th anniversary here. Doug and Tommaso, congratulations on that, and looking forward to much more to come. Thank you, of course, for the kind introduction. Excited to be here at the 6G Symposium. Many of you who know me, I see many friends around, know that I'm an optimist by heart. Certainly looking around and seeing all of you here, though, that optimism is only strengthened here. I see the right mix, of course, of experience, dedication, creativity that we'll all need to succeed in our shared 6G future. This network evolution, I believe, presents the opportunity on an enormous scale, and so look forward to working with everyone here in the room here today. I'm certainly clear-eyed as well of the very real complex challenges that we face here, challenges that could threaten the collective vision of a more connected, more prosperous 6G ecosystem. And so events like these are absolutely important. They provide the opportunities, as we've heard, these conversations that we need to share and discuss the path forward. Whatever happens, I believe, on the next 18 to 24 months, it's an absolutely critical period for 6G. So we need a concerted strategy, overcoming obstacles, ensuring that this rapidly developing technology reaches its full potential. And the successful rollout of 6G holds the promise of a more vibrant economy, sustainable networks, and of course, connecting communities, something that you heard is amongst the very highest priorities that I have as a commissioner. And so before we get into that, I think it's important to start the conversation about what we will need to get there. Because what we're doing now with 5G and 5G Advanced, of course, will set the stage for 6G, and so this work is pressing, and it's timely for this symposium here today. When I look at the contemporary landscape, I see important trends that are gaining momentum that will eventually represent cornerstones, I think, of the 6G networks. And so I'm excited about the ways the networks are becoming more nimble, more secure, more intelligent. While many of these advancements are in early stages, in my mind, they offer a glimpse of the promise of what our 6G networks will offer. And so one major trend that I want to talk about for a minute that holds immense promise, I think, is disaggregation. Of course, decoupling hardware and software functions of network components means that they can be sourced from multiple vendors. With a modular stack, network operators will have new flexibility to incorporate products and services that best fit their needs. And they can swap components and make upgrades quickly. While we're still in these stages, I think important progress is made here and will continue to accelerate. There is no doubt that these open platforms are starting to really take root. Domestically, at least one nationwide carrier, of course, is rolling out a cloud-native Open RAN network. Globally, There have been more than 100 Open RAN deployments in both greenfield and brownfield environments. Network operators are pushing the boundaries of what's possible with Open RAN. We're all watching closely. And while 6G service may be, as we heard, some years away, carriers installing Open RAN radios may ultimately have the ability to upgrade those units via 6G software updates rather than costly hardware and replacement efforts that way. And so while progress on Open RAN can and should be, I think, spearheaded by the private sector, the federal government has an important role to play in supporting this maturation. For years now, of course, it's no secret to you all here, the federal government has been working hard to ensure that these concepts come to fruition, supporting the development and deployment of Open RAN. From basic research through deployment, it will take all of us working together on this technological innovation and the whole of government approach, as we've heard from NTIA to others, that is well underway to see this technology through. At the FCC, I'm happy to say that we are doing our part. We recently adopted the 5G Mobility Fund, which will include up to $900 million in incentives for Open RAN deployment. And so this critical fund is going to help bring 5G connectivity to areas of the United States that currently lack it. And so by incorporating these incentives into the order that I voted on, we're hoping and helping rural parts of the country will benefit from these advances in technology. As somebody who's a native Kansan, ensuring that our rural communities have a critical seat at the table has been a core value of mine as a commissioner and at the commission. I firmly believe that no matter your zip code, how much money you make, everyone deserves to benefit from this important and critical innovation. NTIA continues to make decisive progress as well in implementing the $1.5 billion Public Wireless Supply Chain Innovation Fund that is supporting deployment of Open RAN networks. This fund is laying the foundation for broader adoption by addressing some of the most fundamental challenges in the Open RAN environment. That is consistent testing and commercial scale deployments. Just last week, NTIA hosted the 2024 International Open RAN Symposium. Many of you I know were there and valued that experience in Golden, Colorado. That sounds nice, doesn't it? Golden, Colorado. But attendees, of course, were there from over 200 countries to see, 20 countries. But that symposium really reiterated the administration's commitment to supporting vibrant global marketplaces for Open RAN. This program, in particular, is solving the specific challenges in O-RAN maturation, and I hope and expect that there will be more to come. As network functions jump from hardware to software on disaggregated networks, operators will have more flexibility than ever before without the constraints of physical equipment. Operators will be free to provision resources where they're needed the most, responding to the network's needs in very real time. Virtualized networks will also be customizable in a way that supports tailored services to meet the unique needs of customers. And so with 6G, operators, I believe, will have an unprecedented ability to divvy up the infrastructure with multiple virtual networks optimized for different use cases, all operating simultaneously. For customers, this will be like getting your own bespoke network built to your exact specifications. And so for operators, this means new ways to monetize the significant capital investment associated with network infrastructure. But of course, these network advances can only do so much, in my mind, if to come to a very pressing need, if we are providing the spectrum that they need to operate. And on that front, there is a very real challenge, as everyone in this room no doubt knows. The FCC has been without auction authority since March of 2023. This auction authority isn't just foundational just to the agency and to the development of 6G. I think it's foundational to our country as a whole. The Commission's auction authority drives innovation, enhances competition, and strengthens our national security. Put plainly, auctions help us free up the spectrum and put it into the hands of those who value it, quite simply, the most. Auctions are a critical part of a broader strategy driving advancements into wireless communications. They support better networks, greater innovations in chips, devices, connected applications, all areas of strength for our U.S. companies. And restoring this critical authority is a national and economic imperative. Despite this lapse, we are making crucial progress. We're well on our way to implementing the National Spectrum Strategy. I hope you'll hear, of course, more and more about that over your 2 days here. Execution of that strategy is a vital down payment on 6G. By taking an all-of-the-above approach, this plan puts more spectrum on the table than even was anticipated. Almost 2,800 megahertz versus the target goal of 1,500. It includes a mix of bands. Will support licensed, unlicensed, shared models, all tools that are going to be important on our 6G networks. One of my very first actions as a commissioner was to approve an order in the Commission's Spectrum Horizons proceeding, for those of you who remember that. In that decision, we opened up the 95 gigahertz to 3 terahertz frequency bands for experimental and unlicensed use. No doubt some of the academics that are here and that you'll hear from over the course of your sessions here will hopefully highlight that issue. Right now, universities across the country are performing that valued and valuable research on the future of wireless infrastructure models, technologies, and those critical use cases. So while we've accomplished much in laying the groundwork for 6G and its transition, it's clear that there is much more work to do. Earlier this year, we made some very important progress when the White House forged a broad international consensus on shared principles for the research and development of 6G. This agreement buttressed open, interoperable, and secure connectivity, and so leveraging the strength of our shared commitments to market economies and transparency will ensure that those values are baked in and not bolted on. The importance of these principle-based agreements, I think, cannot be overstated. And so with them, without them, I think we risk falling short of 6G's full potential. And you know, what I think 6G networks could mean ultimately for what I have on the vision board of sustainability and the environment that I would like to kind of illustrate for a few moments here. On that point, 6G presents an environmental challenge as well as a unique opportunity. Like 5G, 6G has the potential to increase radically energy efficiency, reduce our emissions in areas like manufacturing and agriculture, transportation, but it's not going to come easy. We can't take it for granted. We've got to do the hard work. And so in 2020, the information and communication technology sector was responsible for approximately 4% of global energy consumption and approximately 1.4% of global greenhouse gas emissions. As data-rich, high bandwidth applications enabled advanced 5G and 6G ultimately to proliferate, so too, of course, will mobile data traffic. GSMA Intelligence predicts that by 2030, mobile data traffic is expected to grow more than 4-fold, reaching over 5,400 exabytes. Think about that. 6G, of course, will be the first wireless technology that incorporates artificial intelligence, something that I'm the first to mention, but no doubt will not be the last. We're all thinking hard about AI, but with the foundation of fully merged mobile and cloud systems, this will allow for tremendous increases in speed and efficiency, permitting those use cases that we all are still dreaming up, but it will also mean a dramatic rise in the amount of data being generated and used to train these AI models. That is, of course, a massive increase in energy use in order to accommodate that new compute power that we'll need throughout our networks. And so in a massive centralized data centers, but distributed across the networks all the way to the edge in so many ways. And so what can we do to ensure that 6G is an asset rather than a liability in our shared vision for sustainable networks? And so as we focus on enabling others to reduce emissions, we must also find ways to reduce the carbon footprint ourselves. In 2019, I worked hand in hand, shoulder to shoulder with a major telecom carrier on a first-of-its-kind commitment to make its 5G operations and related supply chain carbon neutral by 2025, and we have to make sure that the next generation standards, 6G and beyond, double down on energy efficiency. And that starts right now. We've taken steps in the right directions. The White House's International 6G Principles Agreement encourages, quote, energy efficient deployments and operation, improving both environmental sustainability, repairability, and recyclability of equipment, close quote. 3GPP is also stepping up to prioritize efficiency in networks by standardizing energy usage measurements, introducing robust protocols for energy management. All of this points to a new environmental paradigm in 6G, using the networks themselves as a large and the biggest tool we can in reducing energy consumption. And so when I look ahead, on my vision board, I see real promise for new strategies that will make 6G our most energy efficient generation yet. Utilizing microsleep techniques, networks can deactivate, reactivate during periods of low activity, conserving energy without impacting user experiences. By implementing new waveform designs, networks will adapt more efficiently to different frequency bands, enhancing spectral efficiency, reducing unnecessary energy expenditures. Dynamic adjustments in the number of active antennae in response to fluctuating traffic loads, allowing for tailored resource allocation based on actual demand. And of course, all of these techniques could be applied across multiple 6G networks simultaneously through something that we all know and hear a lot about, and that's network slicing. Meaning each network slice could be optimized for specific services while minimizing energy consumption based on real-time demands. Best of all, making real commitments to energy efficiency isn't just good for our overall sustainability. I think it's good for operators themselves. Increasing the efficiency of networks will drive down operational costs, free up resources which can be reinvested into the networks to improve consumer experience, and of course, connect more communities. As I've said, and as I started, my optimism here about the future is very clear, but also clear-eyed. The premise of 6G will only be realized through a collective commitment to our shared values. It will take a concerted push, informed by conferences like this, informed by people like you, to help keep us on the right path. And so, as always, many of you know, I view myself and stand by as an open door commissioner. I'm always eager to hear from you all and your expertise, good ideas that should be explored, and working together is the best path for all of us. And so with that, thank you to 6G World for the invitation to join you all here today. I look forward to working with you all as we develop and deploy 6G. Most importantly, work hard, enjoy this symposium, and I'll look forward to talking to you down the road. Thank you.
Great. Thank you, Commissioner Starks. Yeah. Okay, so our next keynote speaker is David Young, and David is the Vice President, ADIS is Vice President of Technology Policy and Government Relations, where he works to advance ADIS's positions with the government agencies, regulatory and legislatory bodies, and industry groups. As part of that role, he leads efforts in NextG Alliance to progress the group's goals with key government agencies and Congress, and he has provided great leadership to NextG Alliance over the past year or so since joining last year. And I've enjoyed working with him at NextG Alliance. So David, we welcome you.
Thank you, Doug, and thank you, Alex. We really value the partnership that ADIS has had with 6G World and look forward to continuing our relationship. As Doug mentioned, it's been about a year since I joined ADIS. I joined as the managing director of the NextG Alliance, and it was my honor and privilege to work with Doug and the rest of the NextG Alliance over this year. Recently, we were lucky to bring in a new person, J.D. Griffith, who is the new managing director of the NextG Alliance, and we're excited to be working with him and to get his fresh ideas and leadership into the NGA. And I have moved into the role, as Doug mentioned, of technology policy and government relations. And this is a role that I had served for many years in previous industry experience, and one that I'm quite comfortable with, and which allowed me to get to know many of the policymakers here in the room and watching online. So as we heard, it's been 5 years. This is the fifth 6G World event. The NextG Alliance has been operating for 4 years and has been a valued partner here. The NextG Alliance, as you all know, of course, is a project of ADIS that brought together people from communication service providers, from vendors, chip makers, research organizations, universities, and government agencies to come together and develop and present a North American vision for the next generation of wireless technologies. Because there was an agreement that North American leadership was an important goal. And over the course of these 4 years, the work has done incredible, the group has done incredible work developing dozens of white papers on a wide variety of subjects, technologies, applications, use cases, sustainability, societal and economic needs, all of these aspects, and use cases, of course, was an important piece of that. Which brings us to the topic of this panel, right? What is the most compelling use case for the NextG? And the answer is, we don't know. We're not going to know, right? There's no way to know. Because we will know because we'll see what works and what the market adopts. But we have to prepare for success. We have to enable all of the different possibilities and the different use cases that will create the opportunity for success. We were happy to present the NextG Alliance's point of view at a 3GPP Stage 1 workshop on IMT 2030 use cases this past May in Rotterdam. And in that presentation, Amitava Ghosh represented ADIS and NextG Alliance and presented the use cases that we saw as being the primary use cases that needed to be included in 6G from day one, or that were important pieces of it. So as Commissioner Starks already mentioned, the multi-sensory extended reality is one of those key use cases. Another is the personalized user experience, being able to take a wide variety of information and overlay it with the user's environment and make it relevant to the user in their particular application. Robotics, bringing together the capabilities of robotics in a wide variety of applications that takes advantage of sensing and real-time network communications to enable the safe use of robotics interacting with people in real time. Digital twins that create a virtual representation of the real world and can dynamically update that twin in real time as the network or use case for that digital twin changes. It can be used for planning purposes, for real-time control, a wide variety of uses for that particular use case. Ambient Internet of Things, widely deployed IoT, smart factories, connected vehicles, intelligent transportation systems. Low power wide area is a very important use case that the NextG Alliance members feel needs to be part of 6G early on. And the reason for that is that today that use case is being served by LTE technologies, and so that needs to be a part of 6G from day one in order to facilitate and enable those low power wide area applications with 6G technologies. And then the last one, another really important North American focus, is fixed wireless access. And this is one that is really important. Today, 5G, of course, is being used to provide fixed wireless access in the US very effectively. But the 5G network was not designed with that in mind. It wasn't engineered and designed to provide that fixed wireless access. And so 6G should be considered from the ground up in order to support that particular use case. But beyond these advanced, I think we can't ignore the most compelling use cases, which are going to continue to be the smartphones and mobile broadband and voice and messaging services that we all come to rely on. And so this is an expectation. It has to be there, and it has to support all of the necessary capabilities like public safety and those critical needs. So how do you take all these use cases? How do you apply them? And what is the business opportunity? What is the market opportunity? Looking beyond the smartphone market, you really need to get into vertical markets in order to advance many of these use cases. And so there's a lot of focus on the different vertical markets, and the NextG Alliance has done work in that area. Agriculture we see as one of the key early opportunities for these types of technologies, and 6G we expect can play an important role in these agricultural use cases. Automotive, obviously, very clear, 6G is going to have to play there. Mining is something that can be enhanced by the types of capabilities that these use cases bring. Public safety, e-health, smart city services, all of these, are important vertical markets that have to be understood. The markets have to be understood. 6G success is going to depend on understanding the market itself, that vertical itself, and also making sure that the participants in that vertical, the users themselves and the supplier chains and the integrators who work with those verticals all understand what 6G brings to the table and are prepared to enable those capabilities and bring them to the vertical market early on, so we don't have a large lag from the time that 6G comes to market to the time that these capabilities are being put to their best use in these different vertical markets. Education, gaming, and entertainment, we lump those together because it requires a lot of the same gamification and production values in order to make it a meaningful and robust use case. And then finally, of course, industrial manufacturing and logistics, all of that, are key verticals. So, we see a lot going on now with 5G really starting to make some inroads in these verticals. And that's really important because we need to be able to take the learnings from the 5G deployments, from the 5G scenarios, bring that back and apply that to not only the 6G standards work, but also to, again, as I said, preparing the market and enabling the market for adoption of 6G technologies by these verticals when they come along. So putting all of that aside, there are obviously foundational elements, and Commissioner Starks touched on a lot of these things. We have from the beginning seen that 6G has the potential to bring real value to society and to address real societal and economic needs. And so that means it has to improve public safety. It has to promote digital equity. We need to make sure that 6G enhances privacy and trust as we move to it. And then finally, driving economic growth. All of these are important foundational elements. Additionally, the sustainability piece, Commissioner Starks very eloquently talked about the importance of that. And over the course of the next day and a half, you will hear about all of these things in more detail. The U.S. government clearly has taken strong interest in these technologies, 6G generally, and wireless technologies, more generally, and so we've heard about the FCC, NTIA, Congress, Defense, and we'll have a panel following this that will drill down even deeper into all of that, and I'm looking forward to that discussion. So, in conclusion, I think that the technologies are the exciting part, and the new developments, things like joint sensing and communications, are the things that are going to enable use cases that really can only begin to be imagined, and we'll have to see how it all plays out. But it is an exciting time to be a part of this industry. There are a lot of challenges. The spectrum is a huge challenge. We heard about that. We'll hear a lot more about that in panels coming up. But it's a great industry to be a part of. I am very happy to be here delivering this presentation, and again, happy to work with 6G World and all of you. So thank you very much. And Doug, I don't know, we have a couple minutes maybe.
Yeah, I think we do have a few minutes. Are there questions? We can maybe take one or two questions. Scan the audience. There's no, oh, here we go, Roger. Oh, give you the mic.
So I'm going to ask the tough question here. Last year was kind of the first time there was a good discussion on lessons learned for 5G and what we ought to keep in mind for 6G. And one of those was engaging earlier with the verticals in order for this very purpose, the use case thing. And that's become more obvious to me that as a gap, groups speaking different languages and everything. So could you talk to that a little bit about sort of what ETIS is doing and also how NextG Alliance is approaching this?
It is a great question, and one that is being addressed. I don't want to steal JD's thunder because he is giving this a lot of thought, and but we're talking with our membership about how to take those learnings and bring them back. As I said, part of it is we are really just starting to see some of the 5G deployments in some of the key verticals. And so I think there's a lot that we're going to be able to learn from those and bring back from those. But we are looking at ways that we can proactively engage with companies and associations and even perhaps government agencies that are associated with these verticals. So Department of Agriculture for farming, Interior for minerals, so there are, I think more to come, but it is kind of the critical question to make sure that the verticals are successfully developed once the 6G technologies are available, and that the 6G is developed in a way that will meet the needs of all of those verticals.
Okay, any other questions? Okay, oh, Mitch, be the last question.
Thank you, Doug. Yeah, thank you, David. This is Mitch Tseng with E3. I actually got when you first opened up the speech, I said, okay, you got a solution. Then you say, I don't know. Right. So now, right now, you just kind of point out that we're focusing on these vertical applications, use cases. So I understand that there are maybe some people in the industry still waiting for killer applications for 6G. Right, so what would be your advice then? Like, should we continue on 5G and then when it's ready, then we use more technology to boost that, or we can just wait and see right now? Thank you.
Good question, Mitch. No, I think we can't just wait and see. I think that 5G was designed with certain capabilities in mind and the ability to support a wide range of vertical use cases, but we haven't seen those adopted quite as quickly as I think people originally anticipated. So I think the industry collectively has to do two things at the same time. One, I think we need to figure out how to use 5G as effectively as possible and really get the full benefits of the investments that have been made there, and to bring those into these markets and learn what works and what doesn't work, and then take that back for the next generation and future generations of the wireless network technologies. But at the same time, there are advanced capabilities that we already know that we want, already know that we can incorporate, and that there are emerging use cases for, again, the joint sensing and communications to me is one of those that is really a game changer, but we don't know exactly how yet. So I'm out of time over, but thank you.
Thank you very much, David. And I'm going to hand this back to Tommaso to introduce our last keynote.
Thanks, Doug. My pleasure to introduce now our third keynote speaker for today, Dr. Peter Vetter, who is the president of Bell Labs Core Research at Nokia, out of the Murray Hill, New Jersey office. Peter is leading an eminent global team with a mission to invent game-changing innovations that define the future of networks. Under his leadership, the Bell Labs Access and Device Research Lab made some of its most significant discoveries and established new milestones in fixed and wireless communications. Many of those innovations form the backbone of Nokia's mobile and broadband products today. Peter is a Bell Labs Fellow and an IEEE Fellow. Peter, it's a pleasure to have you here today. Thank you.
So thanks Tommaso for this kind introduction. So in this session about use cases, I thought I should talk about our vision of the digital physical fusion, which is a vision that we have been pursuing already for more than 5 years. And I'll move to the clicker. It's very much about having digital twin models of the physical world in real time, digital twin models of ourselves in real time in the digital world, allowing for enhancing human productivity. So it's enabling this immersive communication that previous speakers already spoke about, the ability of transporting our own model to another location, recreating an environment and having that communication as if we are there. And also digital twins, as in industrial digital twins that help to enhance the productivity and efficiency. But let me explain that in a way with an example that we have been using already for more than a decade. The digital maps. It allowed me to figure out this location and how to best get here. It even allowed me, thanks to the real state of the traffic, an estimated time of arrival. And it enabled new applications by companies like Uber and Lyft that figured out, thanks to GPS localization, I know where my assets are, I know where my customers are, and in an automated way, make a good match and do business. And then they figured out, I can do other businesses than only driver services. I can do food delivery services. So this is an example of how you can use a platform to enable new applications if you make it open. Now imagine a more sophisticated digital twin. Say, for instance, of Reagan National Airport, the airport that I came through. If you have a very accurate model of that airport in real time, multiple parties and service providers in that airport can benefit from that digital twin in terms of optimizing the luggage delivery, understanding the flow of passengers and enabling security services, or also supply to retail stores, or also the logistics of airplanes and the technologies and repair. But it's not only that the open platform enables multiple users, it also enables multiple parties to contribute to that digital twin platform and make it richer, more accurate. The security cameras of the security company are not only there for surveillance, they can be used to make that digital twin more accurate. Same is true for localization services, same is true for the luggage tags, or also service providers that do the multimedia rendering, the XR reality, so that humans can intuitively interact with that digital twin. And then there's the plain vanilla infrastructure, the multi-cloud, making that available, data analytics, AI capabilities, and then very central to all of that is the network. And that enables not only use cases in the airport that I described, but many other verticals that were already mentioned, for instance, by Dave. Think healthcare, things at a large scale, smart cities, co-design, think agriculture, smart manufacturing planning, or also power grids, and many, many more. I'll explain a few examples of collaborations that we had with industries. As mentioned, it's important to learn early what the use cases are, what the requirements for the network are. So one example is a digital twin of a warehouse that we are actually in the process of commercializing. On the left-hand side, you can see how we take an inventory of a warehouse by flying drones that go through the warehouse. And on the right-hand side, you see a graphical rendering and 3D reconstruction of the digital twin. And as the drone detects new boxes, these new boxes are being added to the digital twin and rendered. Interacting with the digital twin world is not only through visual rendering, it is also through new AI capabilities and natural languages. As an example, natural languages can create better context of the digital twin world, adding a vocabulary. And then in the use case on the right-hand side, we had a robot, when we said fire, figure out by itself where to find a fire extinguisher. And I'll do that back again. No, once more. Okay, you should see the video. We shouted fire at the robot, and the robot by itself figured out where in the digital twin world is the fire extinguisher and went there. And so this was possible thanks to the digital twin world, but also thanks to the natural language models applied to it. The robot we did not need to program the robot to get the fire extinguisher. So this is another way of making good use thanks to AI and digital twins. Then here is another vertical, digital mines. In digital mines, open pit mines, you have these trucks, autonomous trucks driving around, and the mine is constantly changing. They're dynamiting the mine, and so to enable safe driving of these trucks in the mine, you need to dynamically update these digital twins. And this is a point cloud image that we have taken by a drone, but then in addition to that, there's not only the visual of the mine, there's other parameters, and we have equipped these trucks with digital twin black boxes that have multiple sensors on them, amongst them finding out the bumps in the road with motion sensors, or also RF signal strength. And then by mapping the real-time RF signal strength, we are updating the RF digital twin of the mine. So it's not only the 3D geometry, it's also other parameters that you can layer onto your digital twin to get a better understanding of the physical world. And these RF maps are obviously very useful to then optimize the wireless quality of service in your changing environment. It was already mentioned, we need many different types of sensors to keep that digital twin up to date, and a new sensing modality is the use of the wireless base stations that are ubiquitously around us. Well, we can use them also as a radar. And joint communication and sensing is the concept that you don't impair the quality of service of your connectivity while at the same time allowing for scanning the environment. And we've built here a prototype with a 5G millimeter wave system that we hacked to enable that sensing, and we're currently testing it in an experimental factory in Arena 2036 in Germany. And you can localize the presence of people and objects with an accuracy of 1 to 2 feet. And it's not only location, it's also speed. We can also detect heartbeat and biometrics, or rotating fans, which is an indication that we're looking at a piece of equipment. Now, what does all this have to do with 6G? Because we can already do digital twins in 5G. The main point is that with 6G, we will allow these digital twins at a larger scale. Thanks to the open architecture that we're envisaging with application programming interfaces, you can allow multiple parties to benefit from that infrastructure, from that digital twin world, and also multiple parties to contribute to it. And in this way, better monetize the infrastructure capabilities. Then, thanks to security and privacy capabilities, will also enable distributed business models, decentralized decision-making with smart contracts. Thanks to the privacy capabilities, we have guardrails to share data in a privacy-preserving way. In order to keep that digital twin up to date, as accurate as possible in real time, will allow for massive scale deployment of sensors, different types of modalities. Several of these sensors will have video-rich content. And there's also the interaction with the digital twin world through mixed reality and possibly in future holographic experiences. So also the higher capacity of a future 6G network will be an enabler. And then I already mentioned the joint communication and sensing. That is an additional sensing modality in using the ubiquitous radios. And then last but not least, the use of AI. The use of AI not only to help understand what's happening in the digital twin world, but then also creating autonomous services and optimizing and improving the performance. And central to that, I've put a leaf, do that in an energy efficient and sustainable way. So in summary, we see as a future vision for 6G, the fusion of digital and physical worlds, enabling digital twin platforms at scale. Thanks for your attention.
We have time for a couple of questions, I think. Please.
All right. And the designated question for 6G Symposium. Yeah, thank you, Peter. Thank you for the wonderful presentation. And I think that in your last chart, you talk about this, the 6G vision on pretty much on everything. Now, actually, my question would be maybe a little bit more, well, at least it's kind of difficult for me. That is that in one way, we want energy efficiency. Then also in the Commissioner Stark, he also pointed out that 6G will be greener and more energy efficient. But on the other hand, as a technology person, we also promote new services using digital twin. And now we want to add an AI element into digital twin that will boost the energy consumption to a degree. So in your view, how do we kind of draw the balance on this part? Thank you.
Yeah, so not surprised that Mitch is asking a question, but more seriously, yes, there's two sides to it. So on one hand, we need to improve our own footprint in the network, and especially when we go to 10x higher capacity, we don't want that the energy consumption goes up by 10 as well. On the contrary, we pledge that we want to reduce it by, say, 50%. So the energy efficiency needs to improve. And there's multiple ways that can be done, as the commissioner already mentioned, like antenna muting, micro-sleep modes, also advances in silicon photonic with power islands and what have you. And use of AI also with new types of accelerator, with new system-on-chip architectures that make better use of, say, computing memory, of analog computing memory, to improve the energy efficiency by an order of magnitude compared to today's AI accelerators. So that is one part of the story. But then, so that is our own footprint as a telecom network. But then there is also the handprint, of course. These digital twin can also help us optimize the energy efficiencies of industrial processes, of transportation, sometimes even avoiding transportation. So in both ways, I think there's gains to be had.
One last question. I have one. I was wondering if you could elaborate on the role that digital twin might play in enabling future AI native 6G networks, especially in the training and on autonomous networks.
Yeah, thank you. So as we have digital twins of the world, we also have digital twins of the network itself. Digital twins that on one hand can get a real state of the network when we want to deploy a new service. We first try it out in the digital twin before we actually deploy it, so to see that it doesn't break anything. It can also help us in optimizing, for instance, for energy consumption. It can also help in more complex systems, like in analog optical fiber systems. These are very complex, interrelated systems with amplifiers, transmitters, multiple systems that are concurrent. We already today use digital twins to actually first try out before we deploy new configurations. And then also using the RF network digital twins, as I explained, for instance, in the mine or in a harbor where you have a fast changing environment where the RF conditions are changing, and AI can then also again help with understanding what is happening and optimizing for the network.
Thank you. And let's thank Peter for a wonderful keynote. Thank you.